This is a short demonstration of the virtual testing use case um, for the far side simulation managed with the Scale SDM system. Just as a short introduction, here we have a diagram of the workflow that has to be performed for the virtual testing of the far side simulation or load case. And in the first step, the OEM has to go through an iterative development process, which at the end delivers the result data um, to be given to Euro NCAP. If we change to the SDM system where the use case is actually integrated, we start with the input data, which is managed in the scale model part of the SDM system. For this, I am showing the desktop client where we have a navigation part on the left side with 3 windows. On the top window, we have the so-called pool versions of our project. Each pool version contains the entire project data at a specific point in time. In the second window, we have the so-called groups, which are similar to folders in a file system, which contain components and or parameter tables. And in the third window, we have our load cases, which in the Scale SDM system are called run configurations. In the middle part, we have the so-called grid, which is a table-like list of the content corresponding to our selection on the right side. So for example, here I have the keyword files or the input files for the body and white group selected here, which also correspond to the selected load case or run configuration. And last but not least, on the right side of the client, we have several tabs containing detailed information about the current selection. So for my selected include, I can see its history. With its history comments, I can see a 3D preview for it. I can see further properties like who the owner is, what version this is, when it was created, and when it was lastly modified. And last but not least, we have a jobs tab where I can see the current jobs that are running. For example, a synchronization job. For the virtual testing use case, the model integrated here is integrated more or less like any model or car project. There is a specific preset for the virtual testing use case, which shows corresponding groupings for the run configurations or corresponding columns for the components that I want to see. Here is where the user or the simulation engineer develops the model or works on the input data. And as soon as it's time, as soon as the model is ready, this can be submitted to the cluster over the remote submit function. And as soon as the job on the cluster starts running, the user gets live feedback in the desktop client. And part of this job is also some post-processing, which prepares and uploads the result data back to the SDM system. So with this said, we can now continue with the result data. The SDM system also has a web client, which I'm showing right now, which has a a view for working with the result data. This is the view that we have right now in front of us. It's similar but not exactly the same as the one for working with the input data. So on the left side, we also have some navigation windows and some filtering options. In the middle, we have again a grid-like view of the data that's available for us. One line means here one result or test data. In our case, we have only the simulation results. And on the bottom and the left part, the right part, we have several tabs displaying different detailed informations or data that belongs to the selection of the results. And one of the most important tabs from these is the report tab. Here we can select through different web reports. And for the virtual testing use case, we have a Euro NCAP virtual testing and validation report, which is the one we see right now. This report, if I select more, the simulations, this report dynamically loads the result data that's available from the simulations into the report. It displays on the top part a general overview with the legend and with the overall checks as specified by Euro NCAP. And in case any check is not fulfilled by any of the selected simulation result, this is highlighted here in red. And now we can continue to the further report blocks to actually check and see where are these checks coming from. The first one, the first block is the criteria, quality criteria as specified by Euro NCAP. These are a number of values like some ratio between the hourglass energy and the internal energy, either of the entire model or just a dummy. And it has to be underneath some specified values. There are also 115 mandatory channels specified by the Euro NCAP documentation, which are also checked here. And it's not only the number that is checked, but also the specific curves, and also 6 mandatory videos. After the quality criteria, we have the block with the validation of the static model parts. Most of the parts of the input model should not variate or change between the simulations. So in the submission process, for each model part which has to remain static, there is a so-called hash calculated. The value of the hash itself is not that important. The first selected simulation result here is used as a base for the comparison, and all of the following selected simulation results are compared to the base one. And as soon as the hash for any model part from the following simulations differ to the base one, this will be also highlighted in red. For example, if we select an additional one from here, we will see that for the pedals, there is no data available, and for the seatbelt part, the hash is different, which means that that input file was edited compared to the base run. So the user can navigate either manually into the input data of this particular simulation, or this also can be done automatically from here by using the add-on show in scale model. Okay, so back. The next block of the report are the rating criteria. Here we have again a list of key values that are calculated based on the curves from these simulations. And we also have threshold values specified by Euro NCAP. And based on these threshold values, the criteria of the certification is going to be provided for this model. This report also offers the possibility for pass check of these rating criteria. And again, if any of the rating criteria does not meet the requirement or is over the specified threshold, the engineer can check the input data for that. Or in this case, the engineer will probably want to check the curves that these values are calculated from. That's why the following block contains a three-level navigation through the channels available for selected results. This navigation tool is also used for detecting any missing channels. In case any of the mandatory channel is missing, they will be highlighted in red here. But this is also useful, as already said, for checking the curves that deliver these unsatisfactory rating values. And the last part is the part of the mandatory videos, where all of the videos are displayed and can be played simultaneously to also qualitatively check the results of the simulation, or maybe to check why some of the result values are unsatisfactory. The main idea of this report is to offer a very fast and efficient check for the simulation engineer based on the quality and quantity criteria specified by Euro NCAP, which means that the engineer can select the 8 simulations as soon as these were done on the HPC cluster, and look at the overall check. And as soon as there is no error or problem reported here, these simulations are ready for submission to Euro NCAP, which is also easily done by export panel. And here I can select all or only some of the selected results and submit this to the server. And as soon as the result data is ready, I can download a tar file that I can then simply upload to the Euro NCAP server. So that should be more or less it on how to manage virtual testing use cases with the Scale SDM system.